G'day guys, Mr. Bennett here. Today we're going to be looking at different types of nuclear decay. The first one we're going to be looking at is alpha decay. So what happens here, and it doesn't really matter what the elements are, but we've got plutonium, and that's decaying to uranium-236, and it's doing that via alpha decay where it produces a helium particle. Alright, so if we were looking at doing a general reaction, I can show you that in class, and I will do that in class. Alright, so that's a alpha decay. So the main thing there is we're producing an alpha particle. Beta minus decay, now beta minus decay produces an electron. Okay, so again we have a element that goes down to something which has the same atomic mass, but it loses, it actually gains an extra proton. So therefore what we're doing is we're also gaining an extra electron. So that's our beta minus particle, and it's also producing a antineutrino. Alright, so that's that one. And then over here we've got our beta plus decay, and so therefore what's actually happening here is it is getting a what we call a positron. Okay, and it's getting a neutrino and producing that reaction. Alright, so the atomic mass stays the same, but the atomic number decreases by 1 in this particular case. That's the beta plus decay. And then the last one type of decay that we actually have is a gamma decay, and so therefore all that's doing is when it's decaying, it's producing a high energy gamma ray. Alright, so actually there's nothing really happens with that. Now, interesting enough, when we start looking alpha, beta, gamma decay, we're generally producing gamma decay in most of those reactions as well. It goes via a series of transitions. Now, when we're looking at the ratio of neutrons to the mass number, the atomic number, this is a ratio of neutrons. So what we see here, when we've got smaller elements, smaller atoms, generally the ratio is 1 to 1. But when we start getting quite big atoms or nuclei, then what actually happens is the ratio of neutrons to the atomic number increases. Alright, so let's say if we had 60 as our atomic number, we're saying the number of neutrons now is over 80, it's about 85 neutrons. So if it's got 60 electrons, it's going to have 60 protons, but it's going to have 85-ish neutrons. Alright, so when we start thinking about predicting what type of decay we're going to have, now anything that's going to be greater than our special number here, and the special number is in fact, the special number is 83. Alright, so anything with an atomic mass number of 83 or more generally will undergo alpha decay as well as gamma decay. Alright, if it's got a ratio where the number of electrons to neutrons falls in this green region, then it'll undergo beta plus decay, or if the ratio is in the red region, then it'll undergo beta minus decay. So we can predict what type of decay is going to occur by looking at the atomic mass compared to the atomic number. Alright, so that's basically how you work that out in terms of what type of decay you'll see things undergo based on where they fall in this particular diagram. Alright, this diagram is quite an important one. Alright, so it's actually relating the atomic number with the number of neutrons in the nucleus, and that will give you an indication of how this thing's going to decay down in the long term. So you do need to understand the decay reactions. Alright, that's a really important part of the radioactive stuff that we're doing here.